Greetings class, my name is Innocent MAPANDA. Thank you for tuning in to your favorite channel. In today's lesson, we are going to touch on June 2023 paper 1 SimSec, the June session, right? So we are going to start with the first question. It reads, a sequence UN is defined by UN is equals to minus 1 to the power of n plus 1 plus 2. Part A, find the first three terms of the sequence. Right, so you'll be guided by the given formula, right? So you're going to find U1 first. So you write U1. So for you to find U1, you simply substitute 1 on n. So you're going to get minus 1 to the power of, then you put 1 on n. It means you get 1 plus 1, which is 2. Then you say plus 2, something like this. So minus 1 squared, you get 1. Plus 2, it means your first term is 3. I hope you are following. Then you find U2. You are going to substitute 2 on n. So 2 plus 1, you get 3. Then you say plus 2, something like this. So if a negative number is raised by an odd power, the negative sign will not disappear. Meaning to say minus 1 to the power of 3, you get minus 1. Then you add it plus 2, it gives you 1. I hope you are following. Then we move on to U3, which is the third term. Remember, the question is requiring the first three terms. So for you to find U3, you are now putting 3 on n. You get minus 1 to the power. 3 plus 1, it gives you 4. Then you add with the 2. So if negative 1 is raised by an even power like 4, the negative sign disappears. You get a positive 1. You add it plus 2. It gives you 3. So this is the solution for part A. Let us move on to part B of the question. State the behavior of the sequence, 1 mark. So you can notice that our sequence is starting with 3, followed by 1, followed by 3, dash, dash, dash. If we were to find the fourth term was going to be 1. So we can say that the sequence behavior is oscillation, or you can say oscillating. Oscillating is a movement of to and fro, right? Or the back and forth movement, where you get 3, then you get 1, you get 3, then you get 1. The behavior, we refer to it as oscillation, or you can write oscillating. So this is the answer for part B. So we are now moving on to question number 2. This is in line with the topic of circular measure, right? We are given a circle with radius r, and there is a sector AOB with angle 2 theta. A and B are 2 points on the circumference of a circle, center O, and radius r, right? The minor arc AB, the minor arc, they are referring to the arc above, which is starting from A up to B. This is your minor arc, right? Subtends an angle 2 theta radians at O, right? If the area of the minor segment is 1/3 of the area of the minor sector AOB, show that 2 theta is equals to 3 sine theta cos theta 4 marks. Right, so you need to understand that the area of a segment is found by the formula half r squared theta minus sine theta. This is the area for segment, right? And the area for sector is found by the formula half r squared theta. So this is segment and this is the sector. So the question is saying the area of minor segment is 1/3 the area of minor sector. So if I substitute 2 theta, you get 2 theta minus sine 2 theta is equals to 1/3 the area of the minor sector. So the minor sector, they are referring to A or B, this sector, right? Which is 1/3 open bracket half the r squared. Remember, the formula is half r squared theta, but on theta, I'm going to put 2 theta, something like this. So we are going to work it out till we reach a stage where 2 theta is equals to 3 sine theta cos theta. So firstly, you can notice that we have got terms which are appearing both sides. Those terms, they cancel off each other, like half r squared and half r squared. They cancel off each other, right? So on the left side, you'll be left out with 2 theta minus sine 2 theta is equals to 1/3 open bracket 2 theta, something like this. Then you are going to move 1/3 2 theta to the left. You get 2 theta minus 1/3 2 theta. Then you move minus sine 2 theta to the right. So it becomes positive sine 2 theta. Right, you can notice that 2 theta minus 1/3 2 theta are like terms, where 2 theta is good as 1 2 theta. So you are simply saying 1 minus 1/3. You get 2/3 2 theta, something like this. Then, according to trig identities, sine 2 theta is good as 2 sine theta cos theta from the double angle identity. Right, so you can notice that this 2 is appearing both sides, so 2 and 2, they can cancel off each other. I hope you are following. Then we do the process of cross multiplication to make 2 theta the subject of the formula. So if we multiply both sides by 3, we get 3 sine theta cos theta. Then you are home and dry. So this is the required solution. Question number 3 is in line with the topic of variation, the one that you did at O level. It reads, a variable p is inversely proportional to the square of 2q plus 1. So firstly, you are going to write p, the variable given, right? Then you put the variation sign. So they are saying inversely. Inversely means 1 over something. So I'm going to write 1 on top to divide 1 with the something that is going to follow after the word inverse is mentioned. So they are saying inversely to the square of 2q plus 1. Square is different from square root. So square, you just write 2q plus 1, then you raise 2q plus 1 with power 2. I hope you are following. So when attacking variation, you come to a stage where the variation sign, this variation sign, has to be replaced by an equal sign. But this triggers the right side, which is 1 over 2q plus 1 squared, to be multiplied by the constant of proportionality, which is k. So if I put equal sign here, I'm going to multiply this right side with k. So the k is going to multiply this one. You get k all over 2q plus 1 squared, something like this. Right, we move on to the question. Find the value of Q when P is equals to 1/3. So the first thing to do before you find the value of Q, you need to calculate or to find the value of K using the complete set. So by complete set, I refer to the value of P and the value of Q given. We are given that P is equals to 3/4 when Q is equals to 2. So I'm going to put 3/4 on P, right? Then you write K all over 2, 2 open bracket, then you put 2 on Q, plus 1 squared, something like this. So 2 times 2, you get 4, plus 1, you get 5. If you raise the 5 with power 2, it becomes 25. So you now have 3/4 is equals to K over 25. Then you multiply both sides by 25 to make K the subject. So you simply multiply 25 with the 3. So 3 times 25, you get 75 over 4 is equals to K. So this is the value of K, and we cannot reduce it since there are no factors of 75 and 4. But if you want, you can express it as a decimal. 75 divided by 4, you get 18,75. So you can say 18,75 is equals to K, right? So let me then put this value of K on this equation. It is going to give you P is equals to 18,75 all over 2Q plus 1 squared, something like this. So this is now a complete law or a complete relationship between P and Q, which enables you to then attack the required question. They want you to find the value of Q when P is 1/3. So you put 1/3 on P, say 1/3 is equals to 18,75 all over 2Q plus 1 squared. Then you cross multiply. So 2Q plus 1 squared is going to multiply 1. Then 3 is going to multiply 18,75. Right? So 2Q plus 1 squared, you get 2Q plus 1 squared. Then 18,75 times 3. It gives you 56,25. So you write 56,25. Right, so you get 2Q plus 1 is equals to plus or minus. Then square root of 56,5, you get 7,5. So you write plus or minus 7,5 here. Right. We are going to say 2Q plus 1 is equals to positive 7,5, or 2Q plus 1 is equals to negative 7,5, something like this. So if you move 1 to the right, you get 7,5 minus 1, giving you 2Q is equals to 6,5. Then if you move 1 to the right, you get minus 7,5 minus 1, giving you 2Q is equals to minus 8,5. I hope you are following. So divide this by 2, then you also divide this by 2. Q is equals to 6,5 divided by 2, you get 3,25. Then minus 8,5 divided by 2, you get minus 4,25. Right, so since there is a condition that Q is positive, it means our final answer becomes Q is equals to 3,25. Then you are home and dry. Number 4, it reads, solve the inequality 1,05 to the power of n minus 1 less than 60. So I'm going to write 1,05 to the power of n minus 4 is less than 60, something like this. You need to take log or take ln both sides. Since we cannot convert 60 to base of 1,05. So take ln both sides. So you get ln 1,05 to the power of n minus 4 is less than ln of 60, something like this. I hope you are following class. Right, then applying the power rule, we are going to bring this power down from the laws of logs. You can bring a down to get a ln p. So same applies. This power n minus 4 is going to be brought down. You get n minus 4. I'm going to put it in brackets. Ln 1,05 is less than ln 60, something like this. So to make n the subject, you are going to divide both sides by ln 1,05. So this time around you are lucky. Why? Because in majority of the inequalities of this kind, they normally give you a number which is 0, something. Ln of a number which starts with 0, something, it gives a negative solution. Like ln 0,5 is negative, ln 0,9 is negative. Ln of a number which starts with 0, something is negative. So if it was ln 0,05, I was going to reverse this inequality. Why? Because whenever you divide both sides by a negative number, the inequality sign must be reversed. So in this case, we are not going to reverse anything since ln 1,05 is a positive number. So these two numbers, they cancel off each other. So I'm now moving minus 4 to the right. You get 4 plus ln 60 divided by ln 1,05. Let me punch this in my calculator. 4 plus, right, ln 60 divided by ln 1,05. You get 87,9. 87,9 to 3 significant figures. So this is the solution. I hope you are following class. Right. This is part A of the question. So part B, it reads, hence state the largest integral value of n, right, for inequality in A. Right, so if you are to prepare a solution set, you can notice that the integer which is going to be largest here is 87. Why? Because 87 is the first integer which is less than 87,9. So other integers like 86, 85, they are going to follow up to negative infinity. But what is the largest? The largest is 87. So on part B, your answer, you are going to write 87. I hope you are following class. Let us move on to question number 5. Right, question number 5, it reads, solve the following simultaneous equation. Xy is equals to 1, 2x plus y is equals to 3, 4 marks. So elimination method on this case is not possible, but you have to make y the subject of the formula in equation number 1 by dividing both sides with x. So you get y is equals to 1 over x if you divide both sides by x. I hope you are following. Let us substitute 1 over x on y. You get 2x plus 1 over x is equals to 3, substituting 1 over x on y. Then I'm going to multiply each and every term both sides by x, where x is representing our LCM. So x times 2x, you get 2x squared. Then x times 1 over x, you get 1. X times 3, you get 3x. So let us move 3x to the left. You get 2x squared minus 3x plus 1 is equals to 0. Let us look for the factors. So you multiply the first term with the last term. You are saying 2x squared times 1, it gives you 2x squared. So we are now looking for two numbers which gives a sum or a difference of minus 3. But when multiplied together, they give you a product of positive 2. The numbers are minus 1 and minus 2. Minus 1 times minus 2, you get positive 2. Minus 1, minus 2, you get negative 3. So we can now write this as minus x, and this minus 2 can be written as minus 2x, so that we apply factorization by grouping. So for factorization by grouping, we are going to remove this middle term, minus 3x, and plug in the two factors, which are minus x and minus 2x, whilst the 2x squared and 1 remains the same. So you get 2x squared minus x minus 2x plus 1 is equals to 0. On this one, you factor out x. X into 2x squared, you get 2x, right? Then x into minus x, you get minus 1. Then you factor out minus 1 here. Minus 1 into 2x, you get 2x. Then minus into plus, you get minus. 1 into 1, you get 1. Then you say is equals to 0. I hope you are following. So you get 2x minus 1. X minus 1 is equals to 0. So this bracket is going to give a root x is equals to 1 over 2. And this bracket is going to give a root x is equals to 1. So these are the values of x, right? So we need to then go back to the first stage where we made y the subject of the formula. On this one, we are saying when x is equals to half, which is the first value of x, what is going to become of y? Y is equals to 1 over half, if you put half on x. So if 1 divides any number, the answer is the reciprocal of the denominator. So reciprocal of 1 over 2 is 2. So the value of y is 2. Then when x is equals to 1, which is the second value of x, what is y? Y is equals to 1 divided by 1, which gives you 1. So in simple terms, we are saying x is equals to half or 1, and y is equals to 2 or 1. And these are the solutions. Then you are home and try. Let us move on to the next question. Right, so question number 6, it reads, differentiate with respect to x. Right, so on the first question, e to the power of 2x sine 3x, we can apply a product rule. Right, so you are saying e to the power of 2x is going to first of all come as it is, then you put dot product so that you differentiate sine 3x. So derivative of sine is positive cos. So you write positive cos 3x, but you then multiply with the derivative of 3x, which is 3. Then you put a positive sign in between. Then I'm now writing sine 3x as it is. Then you put dot product so that you differentiate e to the power of 2x. So derivative of exponential is original function times derivative of the power. So you write the exponential as it is, then you multiply by the derivative of 2x, which is 2. So simplifying, you are now saying 3 times e to the power of 2x times cos 3x, you get 3 e to the power of 2x cos 3x. Then you say plus 2 e to the power of 2x sine 3x, something like this. I hope you are following class. Then you factor out e to the power of 2x. If you want to simplify it further, you can notice that e to the power of 2x is acting as the highest common factor, leaving you with 3 cos 3x plus sine 3x. Then you are home and dry. So this is the first solution. On to part B. For part B, you are simply saying ln open bracket 1 plus x squared. To find derivative of a log, you are saying derivative of 1 plus x squared divided by 1 plus x squared. So derivative of 1 is 0. Derivative of x squared is 2x. Then you divide everything by 1 plus x squared. Then you are home and dry. On question number 7, we are given a curve has parametric equations. X is equals to 2t plus 1 over 2t. Y is equals to 2t minus 1 over 2t, where t is a parameter. Right. Find x squared and y squared in terms of t. So here I'm going to start by writing x first. X is equals to 2t plus 1 over 2t, something like this. So to find x squared, we are raising 2t plus 1 over 2t with power 2. So this can be expanded directly. To find the first term, you raise this first term 2t by power 2. So power 2, it affects both 2 and t. So 2 squared, it gives you 4. Then if you raise t with power 2, you get t squared. This is your first term. Then to find the middle term, you are simply saying first term times second term times 2. So you are saying 2t, which is your first term, times 1 over 2t, which is your second term. Then you multiply by 2. So you can notice that 2t and 2t, they cancel off each other, leaving you with 2. So my middle term is 2 here. Then plus, to find the last term, you are going to raise this last term with power 2. 1 squared is 1. Then 2t squared, you get 4 t squared. So this is x squared. Then we are given y is equals to 2t minus 1 over 2t, and they want you to find y squared. Right, so if we raise the first term again, with 2 you get 4t squared. Then you are saying 2t, the first term, times minus 1 over 2t, the second term, times 2. This is the way you find the middle term. So 2t and 2t, they cancel off each other. Then minus 1 times 2, you get minus 2. Right, then the last term, minus 1 over 2t, is going to be raised by power 2. It becomes positive. So you get plus 1 over 4t squared. Remember, a negative number raised by an even power is negative. So these are the expressions required for part A of the question. Let us move on to part B. Hence, by evaluating x squared minus y squared, find the Cartesian equation of C. So we are saying x squared minus y squared. We need to subtract the expressions that were obtained in part A. So we are saying 4 t squared plus 2 plus 1 over 4t squared. That was the expression for x squared. Then 4t squared minus 2t plus 1 over 4t squared. That was the expression for, for y squared. So we are going to be using the vertical approach. You simply put negative signs in between the like terms. You can notice that 4t squared minus 4t squared, you get 0, and there's no need for you to write down the 0. Then 2 minus 2, you get 4. Then 1 over 4t squared minus 1 over 4t squared, you get 0. It means the difference of x squared minus y squared is equal to 4. Therefore, the Cartesian equation is x squared minus y squared is equal to 4. This is the answer for the Cartesian equation required. I hope you are following. Let us move on to the next question. Right, so the next question reads, express 1 over square root of x all raised to the power of 4 over 3 in the form x to the power of n. So you are simply saying 1 over x to the power of half, which is good as the square root of x. Remember, square root of x is good as x to the power of half, right? So this x to the power of half is going to be raised by 4 over 3, right? So applying the product of indices, half is going to multiply 4 over 3. So we are saying 2 into 2 is 1, and 2 into 4 is 2. It means you get 2/3. So you are saying 1 over x to the power of 2 over 3, which is good as x to the power of minus 2 over 3, applying the inverse law. So this is the solution. Remember, they want you to give your answer in the form x to the power of n. This is your answer. We move on to item B. 2 to the power of 1,5 divided by 2 to the power of 7 times 16 is equals to 2 to the power of x. In this question, you simply turn everything to same base. Like 16 can be written as 2 to the power of 4. So you are saying 2 to the power of 1,5 over 2 to the power of 7 times 2 to the power of 4, which is denoting 16, is equals to 2 to the power of x, right? So remember, when multiplying numbers with same base, you add the powers. So it means 2 to the power of 1,5. Here you are going to get 2 to the power of 11. Since 2 to the power of 7 times 2 to the power of 4, you are multiplying numbers with same base. So you simply add 7 with 4, you get 11. Then equate this with the 2 to the power of x. You can notice that you are dividing numbers with same base, you subtract powers. So you are now getting 2 to the power of 1,5 minus 11 is equals to 2 to the power of x. I hope you are following. Here you get 2 to the power of negative 9,5 is equals to 2 to the power of x. If you reach a stage where same bases are equal, you ignore the bases and concentrate on the powers. So the answer of x is now exposed. It simply means x is equals to minus 9,5. Then you are warm and dry. Let us move on to the next question. It reads, divide a cubed minus b cubed by a minus b. So here you can even carry out long division, right? A minus b divided by a cubed minus b cubed, something like this. I hope you are following. Right, so you are saying a into a cubed, you get a squared. Then you multiply a squared with these terms. You get a squared times a, get a cubed. Then a squared times minus b, you get minus a squared b. So this is the first thing to do, right? So subtracting a cubed minus a cubed, you get 0, right? Then this negative times this negative is going to give you a positive a squared b. So you write a squared b. Then you bring this minus b cubed down. I hope you are following. So this negative becomes a positive because of this negative sign. Then minus b cubed is brought down. I hope you are following. Let us proceed. A into a squared b, you get ab. So you are now multiplying ab times a, you get a squared b. Then ab times minus b, you get minus b squared. I hope you are following. So if we subtract, this is going to give you 0. Then negative and negative, you get a positive b squared. Then you bring this minus b cubed down, something like this, right? You proceed. A into a b squared, you get b squared. So you're going to write here plus b squared. Then you multiply b squared times a, you get ab squared. Then b squared times minus b, you get minus b cubed. So here you can notice that you get a 0 as your remainder. So it means your final answer is the one that came out on top. It's a squared. The final answer is a squared plus ab plus b squared. Then you are on and dry. Let us move on to the next question. Given that x to the power of 4 plus x squared plus x plus 1 is identical to x squared plus a times x squared minus 1 plus bx plus c. Determine the numerical values of a, b, and c, 4 marks. So what you can do is you can expand. Let me start by writing x to the power of 4 plus x squared plus x plus 1. Then you expand the right side, right? So x squared times x squared, you get x to the power of 4. Then x squared times minus 1, you get minus x squared. A times x squared, you get plus a x squared. Then a times minus 1, you get minus a plus bx plus c, something like this, right? So to find the constants, you are going to equate first the coefficients of x squared. Coefficient of x squared on the left is equal to coefficient of x squared on the right. So the coefficient of x squared on the left, there is a silent 1 here. So you are going to take 1, representing the coefficient of x squared on your left side. Then on your right side, we have a negative 1 here. We also have plus a, something like this. So to find a, you move negative 1 to the left. You get 1 plus 1 is equals to a. Therefore, we are simply saying a is equals to 2. Then to find b, you equate the coefficient of x both sides. The coefficient of x on the left, there is 1. So you write 1 is equals to the coefficient of x on the right. You have b, which is the only coefficient of x on the right. So b is equals to 1. Then to find c, you equate the constant terms. Constant terms are numbers or letters without x. We refer to them as independent terms. So on the left side, we have 1, this one. Then on the right side, we have minus a here. Then we also have plus c, something like this. So since a was found in the first part to be 2, we now have 1 is equals to minus 2 plus c. Then you move minus 2 to the left. 1 plus 2 you get C. Therefore, C is equals to 3. So these are the solutions. I hope you are following class. So let us move on to the next question. Functions h of x and g of x are defined by, then we are given h of x is equals to 3x plus 7. We are also given g of x here, right? So g of x is equals to 6 over 2x minus 4, where x is not allowed to be equivalent to 2, because if we plug 2 on x, this denominator is going to become 0, of which 0 cannot be a denominator, right? So what is the first question? Write down in terms of x the inverse of h to the power of minus 1, it means inverse of h. So to find inverse of h, right, you first of all represent h of x by y. So you are going to write y is equals to 3x plus 7. Then you make x the subject of the formula. So you move 7 to the left, you get y minus 7 is equals to 3x. Then divide both sides by 3, you get y minus 7 all over to 3 is equals to x. I hope you are listening, class. Right, so your inverse is going to be obtained using this side where y is, but you just need to convert y into x. It means your answer becomes x minus 7 over 3, and you are home and dry. So to find inverse of a function, you first of all represent h of x by y, then you make x the subject of the formula. Then the side where y is going to generate our answer, but you just remove this y and substitute x back, and you get x minus 7 over 3. So you don't write y minus 7 over 3, but you write x minus 7 over 3 by placing back x on y, right? Then we move on to item 2 of the question. Write down in terms of h inverse of g, stating the values of x for which the inverse of g is not defined. So the values of x for which the inverse is not defined, we refer to it as the domain. But the values of y for which the function is not defined is the range. So they want you to attach your answer with the domain. I hope you are following. So firstly, what you need to do, you convert g of x into y, like what we did on the first part of the question. So you get y is equals to 6 over 2x minus 4, something like this. Then we want to make x the subject of the formula. So we can do the process of cross multiplication. Y is going to multiply 2x minus 4, then 1 times 6, you get 6. Remove the bracket. You get, even without removing the bracket, you can divide both sides by y. You get 2x minus 4 is equals to 6 over y by dividing both sides with y. Then move minus 4 to the right. You get 2x is equals to 6 over y plus 4. I hope you are following. Then to make x the subject of the formula, I am now dividing each and every term by 2. So 2x divided by 2, you get x. Then 6 over y divided by 2, you get 3 over y. Then 4 divided by 2, it gives you 2. I hope you are following. So for you to get your answer, like what I mentioned earlier on, it is a matter of utilizing the side where y is, but replace y with x. You get your inverse as 3 over x plus 2. Then you are home and dry. But remember, the question wants you to state the domain. And you can notice that for g of x, the domain was x must not be equal to 2. Why? Because placing 2 on 2x, you get 4 minus 4, and 0 is not allowed to be a denominator for inverse functions. So in this case, we need to find the value of x which makes the denominator 0, of which the value of x which makes the denominator 0 is 0 itself. So the domain for the inverse is going to be x is not equal to 0. Then you are home and try. I hope you are following. I want you to stay tuned as we move on to the next part of the question. Right, you are now on part B of the question. It reads, sketch the graph of h of x and inverse of h on the same axis, making clear the relationship between the two graphs. So the first thing, even before sketching, you need to understand that if we plot the function and its inverse on the same Cartesian plane, they form a reflection where y is equal to x is the mirror line. So remember, inverse of h, we found it to be x minus 7 over 3, and the original function is 3x plus 7. So we want to sketch these two graphs on the same Cartesian plane. I hope you are following class. Right. Here we can say y is equal to 3x plus 7, representing h of x. So creating the table values, we need to find the value of y when x is 0 and the value of x when y is 0. So if we put 0 on x, you find out that y is 7. We have 0 and 7. Then if we put 0 on y, you get 0 is equals to 3x plus 7, right? Which gives you minus 7 is equals to 3x, which gives you minus 7 over 3 is equals to x, and you get minus 2 and a third is equals to x. This is your second point, minus 2 and a third. So if we are to plot on the graph, let's say this is 0 and 7. This is 0 and 7. Then we now need minus 2 and a third. And this is minus 2 and a third. You put minus 2 and a third here. I hope you are following. Then if you connect the 2 points, you get h of x, something like this. I hope you are following. Right. So what I'm trying to say is, if you plot these two graphs on the same Cartesian plane, they will be reflected by the mirror line y is equal to x. So if we reflect by the mirror line y is equal to x, it means right, you are now on question number 11. It reads, prove by induction that this summation is going to give us this sum. Then you are given 7 marks. So if you are following my tutorials, I did a video on proof by mathematical induction recently. There are stages or processes that are supposed to be followed. The first thing is you introduce the statement by saying, let Pn denotes the statement summation of this is equals to this, right? Then after that, you start with stage 1, which we refer to as the basic step. I hope you are following. We want to prove that n is equals to 1. Right. So by basic step, we are saying the first term of a sequence or the first term of a series is equivalent to the sum of the first term. Let's say if you have got a sequence like 2 plus 4 plus 6 in AP where common difference is 2. 2 denotes U1. This 2 denotes U1. But you can notice that U1 is equivalent to S1. It means sum of the first term, which is 2, is equals to the first term itself, which is 2. I hope you are following. So for basic step, we are saying if we plug 1 on R, you get the first term. But if you plug 1 on N, you get the sum of the first term. So sum of the first term and the first term itself must agree. I hope you are following. But we are saying U1 is equals to S1, but U2 is not equivalent to S2. So from U2 onwards, the term and the sum are not equal. I hope you are following. They are only equal for the first term and the sum of the first term. Take note of that. It is very, very important and very crucial. Right. Let us proceed. So to prove that Pn is true, the left side where terms are found must be equivalent to the right side where the first sum of the first term is found. So I'm going to start with the left-hand side. On the left-hand side, I'm going to put 1 on R to find the first term. You get A, P. You put 1 on R, so you get 1 minus 1. It gives you A, P to the power of 0. Applying the laws of indices, any number raised to the power of 0 is 1. So the left side becomes A. So I'm now moving to the right-hand side to find the sum of the first term. So this A is good as U1, which is our first term. I hope you are following. Let us move on to the right-hand side. You are saying A, open bracket, P to the power of 1. You are putting 1 on N minus 1 divided by P minus 1. Then P to the power of 1 is good as P. So it means this bracket is going to cancel off with the denominator, leaving you with A, which is more of the sum of the first term. So you can notice that left-hand side, right? You are saying since our left-hand side is equals to our right-hand side, therefore, Pn is true when n is equals to 1. So we have proved on the basic step. So from the basic step, we move on to the next stage, which we refer to as the assumption step. On assumption step, we are not proving anything, but we are assuming. We are not proving anything, but we are assuming that Pn is going to be true when n is equals to k. So I'm going to substitute k on the left and k on the right. So you get summation. You put k on n here. So you get r is equals to 1. Then a p to the power of r minus 1. I want you to notice something. On the basic step, we have the right to put 1 on R. Why? Because we are assuming that U1 is equals to S1. But U2, U3 onwards is not equivalent to S2. So we do not have the right whatsoever to put K on R. I hope you are following. We only put K on R in the basic step where U1 is equals to S1. So on this one, when substituting N is equals to K on your left side, you only put K on N. I hope you are following, class. But you don't put K on R. Right, then we move on to the right side. We want to put K on N. You get A, open bracket, P to the power of K minus 1 all over 2 P minus 1, something like this. Then you are warm and dry. Nothing more is needed. This is your assumption stage. Then from the assumption stage, you are now moving on to the thesis stage. So thesis is done when n is equals to k plus 1. What is the reason for thesis? Thesis is going to denote what you call a goal or the target. I hope you are following. So I'm putting k plus 1, right, on n both sides. You get summation of k plus 1 is placed on n here. Then r is equals to 1. A p to the power of r minus 1 is going to come as it is. Don't put k plus 1 on r. I have mentioned it earlier. Then on the right side, you are going to say a, open bracket, p to the power of k plus 1 minus 1 all over 2 p minus 1. Then this is your thesis. So it means when carrying out the inductive step, we need to work out the inductive step until we get something like this, which is your goal or your target. So inductive step is carried out to prove that Pn is going to be true when n is equals to k plus 1. I hope you are following. Right, so according to inductive step, we are saying assumption step is going to be added by k plus 1th term. Assumption step is going to be added by k plus 1th term. I hope you are following. So the assumption step is going to be taken as it is. Where is our assumption? The assumption step is a, open bracket, p to the power of k minus 1 divided by p minus 1. So I'm going to write a, open bracket, p to the power of k minus 1 divided by p minus 1. This is your assumption step. So this assumption is going to be added with k plus 1th term. So you now have the right to substitute k plus 1 on r. Why? Because you are finding the k plus 1th term, which is found using the nth term. So you are saying a, p, then on r, you put k plus 1 on r, but you have a negative 1. So you are going to subtract 1, something like this. So we need to work this out until it matches our thesis, which is our goal. So we need to make sure that we simplify this further until we get this goal, which is your thesis. I hope you are following, class. And so you get a, p to the power of k minus 1 divided by p minus 1 plus a p to the power of k. Since 1 minus 1, you get 0. So this one becomes a p to the power of k over 1. Then you want to make this a single denominator. So p minus 1 times 1, you get your LCM. Your LCM is p minus 1. I hope you are following, class. Then p minus 1 into p minus 1, you get 1. Then 1 multiplied by a p to the power of k minus 1. You get a p to the power of k minus 1. I hope you are following, class. Then 1 into p minus 1, you get p minus 1. So you are saying plus a to the power of k is going to multiply p minus 1. Then we are now removing the bracket above. You get a p to the power of k minus a, right? Then here you get plus a p to the power of k plus 1. Why? Because if you multiply p to the power of k with the p, you get p to the power of k plus 1 through the laws of indices. Multiplying numbers with the same base, you add the powers. So the multiplication of p to the power of k and p triggered k plus 1. Then a p to the power of k times minus 1, you get minus a p to the power of k all over 2 p minus 1. I hope you are following, class. So you can notice that a p to the power of k and minus a p to the power of k, they give you 0. Therefore, they cancel off each other. I am now starting by writing this positive term, a p to the power of k plus 1 minus A all over 2 P minus 1. Then you factor out A outside as the highest common factor. You get A, open bracket, P to the power of K plus 1 minus 1 all over 2 P minus 1. And this is matching our thesis stage. So you then give your conclusion. I hope you are following that since Pn is true when n is equals to 1, n is equals to k, and n is equals to k plus 1, it is therefore proved by induction that summation given is equals to the sum of the nth term. Then you get yourself the 4 marks. I hope you enjoyed today's lesson. Make sure you subscribe so that you do not miss part 2. If you are watching for the first time, do not forget to click the bell so that when I upload new videos, you will quickly notice. Innocent MAPANDA signing out. Till we meet again. Shalom.